Good afternoon, everyone. I am Iram and I am from Pakistan. I am selected as Chloe student by the Department of Environmental Engineering under the supervision of Professor Bianca Federici, Professor Rosella, and Professor Giorgio Boni. So before starting my presentation, I can tell you one interesting fact that do you know that 70% of landslides in Europe are mainly in Italy? And my topic is also related to the landslides, its analysis, and its implementation of the decision support system for local territorial governments. Starting from the introduction, Liguria region is basically affected by the short duration and intense rainfall events that have triggered the damaged landslides and then caused the local inundations. Basically, the rainfall is the main factor here in Liguria region which can cause the landslides, and rainfall is related to connected with the groundwater level. Hence, the prediction of groundwater level is play a key role in the observation of the landslides. There are some other different approaches for territorial management and the community resilience in the topic of landslides. Also, after the analysis, we can also look for the mitigation measures which already a local community is taking, or what we can add in these mitigation measures more. We can also check the impact of the landslides on river flow. Either it changes the way of the river, or what is the either it pollutes the quality of the river flow or not. So the problem is mainly the rise of the water table due to the intense rainfall. When the water rises, the weight of the sliding movement of the mass, the shear strength of the soil weakens because of the rainfall, and it changes the groundwater level. So it is necessary to analyze the landslide with respect to the groundwater oscillations. So the research question arises that how uncertain is the rainfall in this region, and how the soil properties are play an effective role on this landslides. Now the world is moving towards more data-driven algorithms as compared to the physical one. And I am using this data-driven machine learning algorithms, and I am finding how it can be used to predict the level of the water in the future, and also the type, and what is the number, and what is the distribution of the landslides, and also what other approaches for the territory management and community resilience are important in this context. So the research objective is to evaluate the uncertainty of the rainfall and the soil properties. Also predict the groundwater level by using some machine learning algorithms, because machine learning algorithms are nowadays using more in this in engineering or in any other field, because it takes the historical data and it trains itself by using the historical data, and after this it can predict the the values in the future. And the use of some interdisciplinary approaches for the community development, and also the comparison of different techniques. Either the data-driven models are more feasible than physical models or mathematical models which already used. And so the overall research program is, my program is divided in 4 aspects. Like the first one is I am doing finding the uncertainty of the rainfall by collecting the rainstorm events, and then also by considering the soil properties, what is the type of the soil in that region and how much it can absorb the water. The next thing, as I mentioned, that I am using the machine learning algorithm for the prediction of groundwater level oscillations. And after the prediction, we can suggest some countermeasures for the mitigation of landslides. Also, for the community resilience, we can adopt different other disciplinary approaches. So in the first task, my research start from the IHG model, integrated hydrogeological model, which is already implemented by UNIG. And this model is fed by the rainfall, and it calculates the infiltration by considering the land use and soil moisture of the area. And although there are more spatial or temporal methods used in the analysis of landslides, but for mountainous areas, instead, they are still weaker. Like instead of using physical models, we are shifted towards the data-driven models. So we gather the data of Mendatica Valley. Mendatica Valley having the rainfall and the groundwater level of different piezometers of Mendatica, which is inserted in Mendatica Valley. And then I am now cleaning that data and put it in for the training and validating test, and selecting then the best machine learning algorithms, either it's artificial neural network or support vector machines or decision tree algorithms, which one is suitable for the prediction of groundwater level. Then after the analysis, we will move towards the countermeasures for the mitigation of the landslides. And we can keep in context the different aspects, either of the mitigation measure, either it's engineering aspect or economic aspect or legal or social or environmental aspect of the countermeasure which we have taken. And the last one is the connection of the other disciplinary approaches in our area, like either what is the economic discipline can do in landslides, or other social discipline can do towards the landslides. And this is the possible integrated disciplines for society and environment. Like it is obvious that the landslide study is now developing as a new integrated new integrated discipline for the society and the environment. And it involves different disciplines like social sciences, cultural heritage, and the environment, and the water science and the earth science aspects. So the research outcome in the end will be the prediction of the groundwater for the analysis of the landslides and how uncertain the rain is in the Liguria region, and also some resilience indicators for landslides for community development. Also, I am thinking of engaging of doing some questionnaire from the local communities, what they think about the landslides and what they think, which are the factors mainly for triggering the landslides, and what countermeasures they already taken in preventing the landslides, and or either they want new measures, or still the old measures are still applicable in that area. So and this is from my side. Thank you.